Okay, so on this question, don't be fooled by the 90. That's the name of the stuff. That's called strontium 90. It says that it has a half-life. This half-life stuff should be jumping out at you. Because like I said before, when it's a half-life, the question is going to appear like they didn't give you enough information. As I scan through there, I don't see a percentage anywhere. Anytime the percentage is missing, we're going to split it up because we have to find the rate first. So here's what we're going to do. We're going to start on the left side with the amount at the beginning. It says strontium 90 has a half-life of 25 years. If 200 kilograms were present originally, so that's the part that goes next to the E. The original amount always goes next to your E. And it's telling me that the half-life is 25 years. It's going to take 25 years of it, or 25 years for it to be half of what it was. So I don't know what R is. So if I start off with 200 and the half-life is 25, how much am I going to have left? This time it's going to be 100. It's always half. That's what half-life means. Then we're ready to do the math. We're going to try to isolate the E. To get the E by itself, we're going to divide by 200. And the secret to a half-life is at this step, this will always equal 1/2. Every half-life does that on that part of the math. So then we have E to the 25R. And then we want to convert it to the ln step. So our conversion is going to say ln. I hate this word. ln. And then everything flip-flops. So 25R comes to this side. And then 1/2 goes right there. And then we just divide by 25. So I'll divide by 25 here. That crosses out. So that goes into the calculator. And it's going to be negative. Everything that shrinks becomes a negative R value. So I'm going to have ABC ln of 1/2. I'll just type in 0.5 because I hate this board. And I'll put 25 at the bottom. So negative 0.028. Negative 0.028. So we have to use this answer now in the next part of the question. So the next part of the question says, how much is going to be remaining after 10 years? So we started off with 200. There's always the E. We know that the R was negative 0.028. And they want to know how much is going to remain after 10 years. So this right here has to get multiplied by 10, and now it's all calculator work. So if I go into my calculator, it's 200. Shift ln negative 0.028 times 10. So there would be 151.157. Are you guys getting the hang of it? These problems are done the same way every time. Now, I'm going to go ahead and do one last question because this one is a trick question, and I want to see if you can find what. So it says a radioactive substance has a half-life. Boom. Half-life, I don't see a percent anywhere, so we're going to divide this up right here. So on the first side, we're going to figure out the R. So it says if 200 grams of the substance are initially present, so that puts 200 right here. That means my E has to go right next to it because E is always next to the beginning amount. The half-life is 64 hours, so I'm going to put 64 right here with the R. And then because it's a half-life, that automatically means this is going to be 100, even though it's not in the question. Half-life means there's half left after a certain amount of time has passed. Then we do the math. The math is always the same steps over and over and over. So we divide by 200. These cross out. So you have 1/2 equals E to the 64R. Once you get that E by itself, you're ready to use the ln. So we do ln so that way everything can flip-flop across the equal sign. So we have a 1/2 here, and then a 64 here with R. And then we divide by 64. And that becomes calculator work. So ABC ln of 0.5 Come on, calculator, work for me. There we go. So then we're going to put 64 at the bottom. And it's going to be negative again because the amount shrinks. So it's 0.011. Point negative 0.011, and it's negative. That's your R. So now for the second step. The second step says 200 that you start with. E says how much is going to remain after 4 days? You guys see the trick in this question yet? This right here, yeah. If you guys look at the paragraph right here, the original thing that we calculated was for hours. We can't stick days up here because it's got to be the same as the original problem was. So if we want to convert days to hours, we're going to have to times this by 24. What's 24 times 4? 96. So this would actually be 96 times the R. What was our R? Negative 0.011. So negative 0.011. And I know the formula. This would be the time and this would be the R. When you multiply T and R together, it's the same either way. It doesn't matter which way you write it. But that was right there. That was the trick. This 96 has to be used because they're asking you for days and the original was in hours. So you have to make sure that everything is in the same exact units. Otherwise, it will totally screw up your answer. And that's pretty much it. So you should be able to do the assignment. Sorry, none of these match, but they are very similar. I'll fix it.